So this one is June 2017, Unit 4. Which of the particle is a lepton? Lepton families, there are like quarks family, 6 quarks are there and 6 lepton. So muon, muon is actually a lepton. Neutron is a baryon. Pion is a combination of quark and antiquark. So that is a meson. So this is a meson. This is a baryon. Baryon means like 3 quarks are together. Neutron is also a baryon, 3 quarks. Muon is a lepton. Muon, tau, or electron, these are leptons and along their neutrinos. A beam of electron is traveling. So if electron is moving, which of the following is the direction of a magnetic field? You can work out this, like example, what are the options? It cannot be left to right or right to left, because why it cannot be from left to right or right to left? Otherwise, electron should go, if it was a left to right or right to left, electron should go out of the page or into the page, like because it is moving perpendicular to magnetic field. So either it will be in or out. So example, if I say magnetic field is in, so because it's an electron, so use your right hand, your index finger, the first finger, point towards the magnetic field. So first finger should point into. Your second finger represent the direction of the particle, which direction the particle is moving. So in this example, the particle is moving down. So your second finger should point down. So index finger should point in, the second finger point down. So where the thumb is pointing, automatically when you apply the rule, you'll find your thumb is pointing on the left hand side. And this electron is moving toward the left hand side. So this gives an idea that the field is into the page. Then a toy car rolls down a slope and a graph is plotted against the momentum. Which of the following represent the gradient? So basically, yeah, that's right. Momentum divided by time. So rate of change of momentum or momentum by time is equals to force. So momentum is denoted by P, letter P. So delta P divided by T, that's equal to resultant force. That's correct. Then a beam of electron is investigated. The beam of electron is produced to investigate the wave property of a particle. Like particle can also behave like a wave. Wave can behave like a particle. So the beam is obtained accelerated across a potential. Which of the following decreases the wavelength? So we have the formula E is equals to hc over lambda. If we increase the energy, the wavelength will decrease. So by apply, and how we can increase the energy? Remember the Planck's constant and the de Broglie's wavelength, that lambda is equals to h divided by mv. If I increase the momentum, the wavelength will decrease. So applying a smaller voltage, so it will move slower. So if it moves slower, it means momentum is less, wavelength will be longer. Decreasing a momentum, so if we decrease the momentum, wavelength will increase. Increasing a distance between cathode and anode does not make, like it will even slow down the electron as it has to travel to a longer distance. Increasing the velocity means increasing a momentum or energy reduces the wavelength. So if the particle is moving at a high speed, it means it will have a shorter wavelength. Then accelerators are used to collide high energy particles so their interaction can be studied. Which of the following quantity is not always conserved in the interaction between the particle? The charge is always conserved energy is conserved, momentum is also conserved. Only rest mass. What is the meaning of rest mass? Like the total mass is not conserved. Mass energy is conserved, but not the total mass. Because what happens when the particles are moving, like it will have some energy and mass. This will also have energy and mass. So when they collide with each other, new particle might be formed. It might have the sum of these masses might not be same as the mass of a new particle, but the energy mass of the particle, the interaction before, the sum of energy and mass before will be equal to after. Because the idea is that maybe some of the mass has converted into energy, or some of the energy might convert into mass. So there is not the conservation of the rest mass. Mass energy is conserved. Then in question 6 and 7, the potential of points 2 volts is applied across a parallel plate which are separated by 4 centimeter. What is the electric field strength? So V is equals to ED. So E is equals to V divided by D. V is the potential, we apply 0.2, but the distance is in centimeter, all are in meter, so we divide by 100, 0.04. So 0.2 divided by 0.04, so it will come out as C. Then in question 7, which row of the table possible arrangement of a quarks in a baryon? Baryon means like combination of 3 quarks. It can be all anti-quark, like all anti, or it might be all quarks will be there. And what about the meson? Meson is a combination of a quark. This is 3 quarks. When 3 quarks are there with a combination, baryon. And when 2 quarks are there, but the condition is that one should be a quark, another one is anti-quark. So when quark and anti-quark are joined together, they will form meson. So which one is forming a meson? So either C or D is a meson. And when you check this one, here why this is wrong? Because 2 are anti and 1 is, so it should be either all anti or all otherwise, because particle and its anti-particle, here you can see strange and anti-strange, they annihilate and convert into energy. Like this is not showing a stable configuration. Which of the following is a vector quantity? Kinetic energy, scalar, magnetic field, vector, energy of the free space, scalar, work done is a scalar. Magnetic flux density is B, having a direction from north to south. Permittivity of a free space means how much electric field lines can pass. The diagram shows the 2 particles X and Y moving in the same magnetic field. Look, they're deflecting in the same direction, so their charge should be same. And if the particle is lighter, if the lighter particle, it deviates more and the heavy particle deviate less. So when we compare the mass of the Y, because the Y is deflected more. And the second thing, the thickness of the line, look, 2 things are there. Number 1, the thickness of the line shows the ionizing ability. So what could be the answer here? Because the first one, how we identify charge on Y compared, because they're deviating in the same direction, so it should be same. So either A can be an answer or D can be an answer. We cannot have B or C because they know. Then the second option is we don't have to check, it is constant, like greater. Now what about the speed of the Y? Because Y is Deviating more, so it means it has a smaller radii or less momentum. Momentum and the radius of a curvature, this is having a smaller radii, this will have a large radii. So momentum and radius of curvature is inverse. So the one which is having a smaller radii means it is having the smaller radii, it means it will have sorry, by mistake, momentum and radius are directly proportional. That was about the wavelength in my mind. So momentum and radius of curvature are directly proportional. The one which is having a high momentum will have a greater radius. So X is having a greater momentum, Y is having a smaller momentum. So here momentum will increase, here momentum decreases, here momentum is same, here momentum, yeah, that's right. B is the right answer, because otherwise if I check with the reason why I choose they should have a same charge, because they are deviating in the same direction. But charge of Y, so I thought charge on Y, like if charge on Y and X should be same. But how we can get how we can get the charge of Y is greater? Basically, identification of the charge, as you can see here, what happened, the centripetal force is equal to magnetic force. Centripetal force is given by mv square over r, and magnetic force is given by qvb. So v will cancel with b, so it will be mv divided by r is equals to qb. mv is the momentum divided by qb and into r. So here, to get a smaller value, as you can see, to get a smaller value of a radius, the momentum should be less, the charge should be more. How momentum can be less? Momentum is a product of mass and velocity and the charge on the y. So the charge on the y should be greater, and the momentum, the product of mass and velocity, should be less to get a smaller radii for y. That's why B should be the right answer. Then question 10, non-relativistic particle M, which is having a momentum of P and kinetic energy. Another non-relativistic particle with mass 2m has a momentum P by 2. What is the kinetic energy of the second? Look, what is the relation here? Look, kinetic energy is half mv square, or Ek is half mv square. If I multiply and divide by m, so it will become half m square v square divided by m, Ek. Or Ek is equals to m square v square is momentum square divided by 2m. And what is the relation between kinetic energy and momentum? So kinetic energy is directly proportional to momentum square, and kinetic energy, or Ek, is inversely proportional to mass, according to this relation. Like, because both, if only mass is changing, according to the particle, like relation between the momentum of a particle and the kinetic energy, this is the expression. So what happened in the question? The mass become twice. So if the mass is multiplied by 2, what will happen to kinetic energy? It should divide by 2, according to this relation. And if the momentum is become half, like here, this will become, if I substitute the value, it will be like P become P by 2. So it will be P square by 4. kinetic energy of the second particle. So that is p square by 2m, and this is p by 2 square by 2 into and this one is 2m. Yeah. So ke or ek is equals to, this will be p square by 4, and this is 2 multiplied by 2 because 4 is there. But we want to eliminate, like change, as you can see, ek, the first kinetic energy is p square by 2m. Now new kinetic energy, like I say, ek dash is equals to, this is p by 2 square, because I want this relation so that I can substitute ek value and compare 2, and this is also 2m. When I simplify, it will become p square by 4. This will be 2 and 2m. And when I simplify, this 4 will go there in denominator. So it will be p square, 2 multiplied by 4, that is 8 and 2m. And what is p divided p square by 2m? P square by 2m is ek. So I can say ek dash is equals to ek divided by 8. So the new kinetic energy is ek divided by 8. Or I can also use that relation for the kinetic energy and momentum square and kinetic energy and mass inverse. For the, so the mass is divided, mass is multiplied by 2, kinetic energy will be divided by 2. If momentum is divided by 2, kinetic energy will be divided by 4. So due to change in mass is divided by 2, due to change in momentum also divided by 2. So new kinetic energy divided by 4 divided by 2. So it will be ek by 8. So A will be the right answer.